The polar coordinate used distance and direction to specify the location of a point on a plane. To set up the system, we choose a fixed point O in the plane called the pole or the origin, and draw a ray half-line called the polar axis as in figure. Then each point B can be assigned a polar coordinate P or theta, where r is the distance from O to P, and theta is the angle between the polar axis and the segment PO. Now, theta is positive if it measures counterclockwise, and negative if it measures clockwise. If r is negative, then the point PR is defined to be the point that lies on absolute value of r unit from the pole in the direction of opposite that's given theta. So let's take a look at the first example. Well, the point P, 3 pi over 4. So think of this as the polar coordinate. Each of this is of a unit 1. So here we get 1, 2, 3, 4. So the angle 3 pi over 4 with the radius 3 is this point over here, right? So this is this 3 here. So this is point A with the angle of 3 pi over 4 and radius 3. Point B, you get negative pi over 6, and the radius is positive, so that is 2. So this is point B. Point C is a little bit different. So first of all, we will figure out where is negative pi over 4. Okay, so where's negative pi over 4? Negative pi over 4 is at 7 pi over 4 with the radius of 4, but we have to reflect this across the origin in order to get, because the radius is negative. So 7 pi over 4 reflect over. So this is point C, because it needs to reflect across the pole. Now, grab the point with the polar coordinate P of 2 pi over 3. I'm going to start with theta first. The angle is at pi over 3, and we have the radius 2. So this is the point P. Okay, so let's just draw this distance PO here and just leave it there. Now we want to find two other polar coordinates with the same representation of P, where r is greater than 0, and another one with r is less than 0. So the first one, well, with r greater than 0, so then r is equal to, well, we know this angle here is pi over 3. Well, if I continue around the circle to n pi, I'll end up at the same point, right? So then I will have theta equal pi over 3 plus 2n pi, where n is integer. Then I get the same coordinate with r being positive. What happens if I want r is negative? Then r equal to negative 2. If that was the case, if r negative 2, before we reflected across the x-axis, r being negative 2 would be somewhere over here. This angle here is negative 2 pi over 3. So if I do that, if r equal to negative 2, then theta, I make it to be negative 2 pi over 3 at 2 and pi, which it will always end up at the spot where I want it to be. But because r is negative, it would reflect across the x-axis in order to get to the original point. So then I'll say theta is equal to negative 2 pi over 3 plus 2 n pi, where n is integer. Let's talk about the relationship between the polar and the rectangular coordinate. To change from polar to rectangular coordinate, so let's say, as we have earlier, the point P or theta is a point that have the distance from O to P is r, right? And theta is the angle between PO and the polar axis. I can come up with a right triangle so that the horizontal distance is x and the vertical distance is y. Now here you can see, using basic trigonometry, x then equal to r times cosine theta and y equal r sine theta. So if we want to go from rectangular to polar coordinate, we can make that substitution. Now if we want to change from rectangular to polar coordinate, remember the Pythagorean theorem says we can have r squared equal x squared plus y squared. And using trigonometry, we can say that tangent of theta equal y over x, where x is not 0. Now, first of all, if we want to convert something to a polar coordinate, we need to figure out what quadrant is that point P going to be in, so that we can decide what theta to use. Okay, so convert polar coordinate to rectangular coordinate. So here, the x equal to r theta equal r times cosine theta. That equal 4 times cosine the pi over 6. Well, that equal 4 times root 3 over 2. That is 2 root 2. Y equal r times sine theta. That is 4 times sine the pi over 6. That is 4 times 1/2. That is 2. Well, in the next case, we have x equal root 3 times cosine of negative 5 pi over 3. That is root 3 times 1/2. That is root 3 over 2. Y equal root 3 times sine of negative 5 pi over 3. And that is root 3. So sine of negative 5 pi over 3, that in quadrant 2. So this here have to be a negative 1/2. Make negative root 3 over 2. And here we have root 3 over 2. That is 3 over 2. Okay, so that of quadrant 2. Well, let's take a look at the converting rectangular coordinate to polar coordinate. And we want r being greater than 0. So first of all, here P or theta have to be a point in quadrant 1, because both x and y are positive. R squared equal x squared plus y squared. That is 8 plus 8 equals 16. So r equal 4. Tangent of theta equal root 8 over root 8 equal 1. This means theta equal pi over 4, because it's in quadrant 1. Negative root 6 and root 2. So r squared equal 6 plus 2 equal 8. So r equal 2 root 2. This is the angle. This is a point in quadrant 2. So we have to go with theta accordingly. So tangent of theta equal to root 2 over negative root 6. That is 1 over negative root 3. This means theta is the angle 5 pi over 6. No, 5 pi over 3, right? Nope, I write the first time. This is 5 pi over 6. Yeah. Now, if we want to convert a rectangular equation to polar equation, we recall that x equal r cosine theta and y equal r sine theta. We can use that to substitute into this equation. So here I have r cosine theta plus r sine theta equal 4. I'll go ahead and factor out r. So r equal 4 divided by cosine theta plus sine theta. In the next one, well, recall that x squared plus y squared equal r squared. Then I can write this as r squared squared, make r to the 4 equal 2 times r cosine theta times r sine theta. So r squared equal 2 cosine theta sine theta, and that is sine 2 theta. How do we convert polar equation to rectangular equation? So recall r squared equal x squared plus y squared, and tangent of theta equal y over x. We also know that x equal r cosine theta. So cosine theta equal x over r. That is x over square root of x squared plus y squared. And sine theta similarly become y divided by square root of x squared plus y squared. Well, here I have r, so this is square root of x squared plus y squared equal 3 times 1 minus y over square root of x squared plus y squared. We try to see if we can solve for y. So here we can simplify the left hand side, the right hand side. So that is 3 square root of x squared plus y squared minus y divided by root of x squared plus y squared. So root of x squared plus y squared equal 3 times square root of x squared plus y squared minus y divided by root of x squared plus y squared. So multiply both sides by root of x squared plus y squared. So then x squared plus y squared equal 3 times root of x squared plus y squared minus y. And as you can see here, we cannot implicitly solve for y, so we just leave it as is. This is the best that we can do. And now, I hope you see the reason why we prefer polar coordinates sometimes, right? Because it's be hard to sketch this equation if you have it is x squared plus y squared equal 3 square root of x squared plus y squared minus y. No, but the polar equation, it's so much simpler. It's just r equal 3 times 1 minus sine theta, easier to graph as well. So in the next case, again, we have square root of x squared plus y squared equal 2 divided by 1 minus x over x squared plus y squared. We can simplify by multiplying the numerator and denominator up the right hand side by square root of x squared plus y squared. And that's all we get.